Here in the UK, we don't really have much IPv6 use as the rest of the world perhaps might in regards to uptake. Now, I jump in and out of it from time to time, just depending on what I'm working on, and some things I find interesting, some things I find particularly boring, because it's just an IP address, right? How excited could you get about an IP address? Turns out quite excited, so it seems. But just as a quick nugget, I found this particularly useful. You may not. The title kind of gives it away. If it's not your cup of tea, feel free to move on with your life, and I bid you farewell. Otherwise, stick with me for the next 5 minutes, and I'll go through the use case I have here. So how can we build an end-to-end network with just one IP? Well, it's kind of a misleading title with some IPs. So I ponder you all with a question. Here's our topology we're going to use. It's based on EVE-NG. If you've not seen EVE-NG or tried EVE-NG, I implore you, please go and have a look. It's very easy. Nice for spinning up quick labs. Anyway, quick labs. Question 1. So, given this topology, I've got 4 PEs. Each of the edges of this topology are PEs. The 2 in the middle are P routers. How many IPv4 addresses do I typically need for a flat BGP connectivity between the PEs? So it's all in the global routing table is what I mean here. And I want to have all those PEs having a BGP pairing with each other. So how many IPs would I need to deploy in this topology? Possible answers are as follows. A0 for 1, so 1 per each PE node. Would I need 6, 1 per particular node? Would I need 10, where I'm having for each point-to-point link, I need 2 IPs, so either end of a point-to-point link. 14, so the same as the above use case, each point-to-point link, or 1 per, as well as 1 per each PE, or 16, 1 for each point-to-point link, and 1 per node. So, or other, please leave in your comments. There's many ways, and of course, the answer is it depends. There are some wrong answers here. For example, A is definitely wrong. You can't do this without 0. Personally, for this one, I would go with option E. However, if you'd said D or F, you would also be correct. But I say E, so we've got 1 for each point-to-point link. So I've got an IP address on each interface, and then a loopback IP address on each PE as per best practice. However, you could do BGP pairings over the interface IP, so answer D would have also been correct. And also F, we could say F, we could have an IP address per each node that we use, not only for BGP, but maybe for management purposes. It's nice to have a loopback for management. So our IP addressing plan for V4, at least, would look a little bit something like this, where we've got a /28, which we've carved out. We've got our 1, 2, 3, 4, 5 point-to-point links, which are these point-to-point links here, which equate to 10 IP addresses, so /31s. If you use /31s, pretty cool. It allows you to conserve a bit more IP address space. And then we've got a /30, which is carved up with 4 addresses for each PE. So that's our IP address plan or schema for this particular network. Now, IPv6. Same question applies. Question number 2. How many IPv6 addresses do I need typically for a flat IPv4? So flat global routing table. IPv6. I excuse myself. I will not edit it out because I'm human and fallible. And for BGP connectivity between the PEs. Same answers, although I have to bump them down a little bit. So we've got 0, 4, 6, 10, 16, or 14 or other. And here, actually, IPv6 is pretty good. We could do this with B, answer B, just 4 actually. If we want to do BGP peering from loopback to loopback between the PEs, and here's what that would look like from a plan. So each PE would be given a globally unique IP address, IPv6 address. So this is going to be routable, where the links between the nodes, they're going to just use their link local IP addresses. So yes, although they will have IPv6 addresses on them, they're going to be auto configured by the nodes, and they're going to be non-routable, and you won't need to advertise them or even, in fact, worry about them in the network. And then V4, if we were to do this with V4, just for a counterpart, this is what it looked like, a /30, and we've got 4 addresses. Again, that was answer B. Yes, C is also a very correct answer, because you want to still manage those P nodes. They would need a IP address on them. And And if we're being fully transparent, I mean, I didn't write the RFC or design this, so I take absolutely no criticism to heart whatsoever. But we will also need an IPv4 address on each of those nodes, because the routing protocols, let's assume we're running OSPF and the underlay needs a router ID, which is an IPv4 address or IPv4-like address if you want to be facetious. And same with BGP. BGP needs a process ID, which is an IPv4 address or IPv4 style formatting, if you like. I talk too much, and anyway, so this is great, but let's talk about scale. Boom, there is my copy and paste at the bottom below, because drawing is for, well, I didn't have time. I couldn't be bothered. So let's say we have 10 nodes now. What does this mean? If we have 10 nodes, then for IPv4, then we're going to need 8 point-to-point links. We're going to need 20 IP addresses for management. Why are we going to need 20? 8. Okay, so we need, yeah. What? We've got 10 nodes. I forget what I put myself sometimes. So if we have 10 nodes, we're going to need 8 point-to-point links. We're assuming there's 8 point-to-point links, so we've got a couple of edges there, edges of the tree. 20 IPs for management, which is not true. We need 8 times 2 is 9, 10 plus 10. What? I'm going to go back and see what the hell I've done there. Management. So if we want to manage them, we need 10. Whoa, nearly on. I will cut this a little bit. All right, this is a typo. I'm gonna just resume video here. I ignore the fact that it says this. What I'm gonna do is I'm gonna do this. I'm gonna go, you do not belong. That's supposed to be a big cross. And I'll turn into a hashtag or a pound sign, as I like to call it. If you're modern era, then it'll be, it's called a pound. You call it a hashtag, don't they, these days? Let's get rid of that pen. So we have 10 nodes. 8 point-to-point links are required. Therefore, for IPv4, we're going to need 26 addresses, which is 8 times 2, which is the point-to-point links, plus 10, and the 10 is 1 IPv4 address per node, so we can manage it. Just assuming we need to manage each of them uniquely, which we will. Right. Then we have IPv6, which need 10 IPs, 1 unique IP. IPv6, I should really tack that off the end just so we're clear what we're talking about here on each of the nodes. Now, what about the scale is even bigger? Oh my gosh, you've got 100 routers in your network. It's a lot of routers to manage. But switches, right? We're talking about switches as well. So, a typical campus, this is not unheard of. So there we have 70 point-to-point links. For IPv4, we're going to need 240 addresses. And guess how many you need for IPv6? You got it. 100. 1 per node. Pretty cool stuff. Right, to the backcopter. Sorry, it's the weekend. I do that. On to the CLI. Let's have a quick look at what we can do with this. So over we go. Wrong screen. I'm going to just end the show. Do I want to keep my annotations? We don't want to keep that. Discard. And then I was looking at stock photos of Batman. Okay, here we go. So, onto the CLI. I'm just going to bring this little picture down here up just so we can see where we're going. So, first thing I've done is I've just wiped those boxes to make it a bit easier, and I'm going to deploy the IPv4 script. The powers of the demo people. Hopefully this will work. There we go. Connected to each device, and then it's doing the configuration. So it's done v61, v62. It's going to do them all one by one. So it's a little bit slow, this, but you can see what's going on. Maybe up there. You are. Bit of view. All right. So while that's running, we can just jump on up here. I've got connectivity to. I've got 61 here on the console. I don't know which this one is. Let's have a look. This is 63. And this one is 64. So this guy. If we just do a quick look, we got show. I think I've run OSPF. Excuse me. So it's got an OSPF peering, so it's pushed down OSPF configuration. We need to provide reachability between the Ps so that we can form our BGP overlay. So typically you run an IGP underneath and you run BGP on top and form your peerings that way. You don't have to, but this is how we've done it in this lab. If I do just a quick show IP in BRI there, you see my neighbours are coming up. If I do exclude unassigned, you can see I've got 2 IP addresses. So all my Ps will look like this. Each one will have an IP interface. And I'll loop back used for BGP, and I can see my BGP has come up there. So I do show IP BGP, summary. Sorry about the loud clicking. I think my microphone is built into my keyboard for extra immersion into the video experience you have. So yeah, BGP's up. 1, 2, 3, 4. Tickety boo. Thank you very much. And then you can see here, this is just switch 63 or router 63, node 63. Node 63's got a better into it, I think. Node 63. There can be only one. Now if I do show IP in BRI on me, and when I say BRI, I think of cheese. There is no cheese. I don't like BRI. Actually, it's goat's cheese I'm not particularly fond of. Don't mind BRI. It's a little tasteless, but it'll do. Here we are. 1, 2, 3, 4. We have our 4 IPs, no BGP because we are just a transit node EP node. Good. Not very exciting. I'm not teaching you anything fantastical here. I'm just showing you the way that we do things today. So I'm going to drop out of Telnet here. And the reason I'm doing this, folks, is because I only have console access to those boxes. And if I'm being a console, no! The old elusive domain lookup command. You seem to have typed the command and you don't seem to know what you're doing. Let me see if I can resolve it and just hang for a long time to really cheese you off. I mean, this is just a Cisco 101. We've all been burnt right by this one. And then we all tell ourselves, once this finishes, we'll go back and we'll do no IP domain lookup. And then our train of thought derails while we wait and we go on and forget, and then we come back. It stopped. I'll stop waffling now. And then I go quit. So as I'm saying, I don't want to be a CLI hog or a console hog because the script needs it to wipe Python. Right, guys, girls, ladies and gentlemen, if you are not into doing any level of automation yet, get involved. Right? I thought these took me longer to write the scripts for this video than it would have been to configure it all manually, but once you have the templates in place, it's fantastic. I can do that in another video. There's loads of stuff out there. If you're interested in what I've done here, then just send a message in the comments and say, hey Sam, cool video. You want to see more about that automation? And then you can look at my coding and go, oh my gosh, you need to study coding more. I'm in the crawl, because crawl walk run. I'm crawling. So IPv6. So now let me just show you here quick, just so you're all trusting and believing. If I go onto this node, we can see here it's just a switch now, right? There's nothing on it. If I enable that, show IP in BRI, there's nothing. It's empty. There's no. It's even got the plug and play agent stopped there. So it's a factory reset switch. And why the plug and play agent being a factory reset switch is because the plug and play agent will run until you do some sort of interruption on a factory fresh box, such as interrupt the console by pressing a key. People do it all the time when you're trying to do automation with DNAC. If you see my other video, this is supposed to be like a 5-minute video, and I've been going. If I look at my time with it, 15 minutes. Those of you that are still with me, good job, good job. I'm going to push down the IPv6 config now, and we're going to have a look at that. And yeah, here we go. So V says that one's done. It logs straight out. So we can jump on 61 and have a look at the config. Here we are. And if I do show IP in BRI, remember, show IP in cheese, and I'll do exclude unassigned, and then we can see I've just got the loop back. Yes, I did say we don't need IPv4 addresses, but remember, we need a router ID for OSPF and BGP, so I kind of snuck that in. I have to have it, otherwise it's not going to work, so I'm not really being sneaky. I'm just conforming to what the powers of the CLI, I don't know, what would you call them? The creators, if you like? McP. Have you seen that guy? If I do show version, look, this guy compiled by, where is it? McPre. I mean, I don't know if this is a real person, but he sure is busy. Show IPv6 interface. Is there a brief? I don't know. There we are. So I've got so these are all linked local, FE80. If you don't know the IPv6 convention, then look it up. There's plenty out there. But all I've got is on the loopback. On each of the loopbacks, I've got a host IPv6 address, so a /128 bit address for IPv6. You knew that, right? Of course you did, because you guys are awesome. And if I do show, what's the command? BGP. Show BGP, IPv6, unicast, summary, and then I have BGP neighbors un and deux trois. My French friends out there. It's as much French as I can do. And that's all we have. Check this out. Last one, and then I'm going to go. V63 end show IP improve. I need to exclude that side. So it's just got one. Why do we have that? Well, I'll show run. If I do SRO section root OSPF, it's because I need it for. Actually, I don't even need that on there. There is no. Yes, I do. If I do show IPv6 OSPF neighbors, yeah. Show IPv6 protocols. Yeah, use it for the router ID. I don't know why it wasn't showing up in the output there. Show run section root OSPF. Let's go router and see if it's in. So here's our BGP. Oh, I know why. So this is the old. This is not. This is about IPv6, but let's do OSPF. Seeing as we're here. What do we do when we haven't got a router ID? So the first thing we look at, and I could be wrong. I'm not. I could go and Google this and pause the video, and I know exactly what I'm talking about. But I'm going to try and do this from memory. Do we have a configured router ID under the process? Yes, no. If the answer is yes, then use that. If not, then I'll use the highest. Is it the highest or lowest? I think it's the highest IP address on a given loopback, and else the highest IP address on an up interface. Right. So what we could have done is we could have gone into here, IPv6 router OSPF, and then done our router ID. Yeah, you know, area 51 or 51 or whatever. You know, blah, 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 blah. It's too many numbers. So yeah, that is that. So yeah. In summary, have I got a nice little slide for summary? No, let's just talk. In summary, IPv6 is good because you don't need to configure. Show IPv6 interface brief. You don't need to configure IP addresses and all the transient interfaces. Your point-to-point links uses the link local IP addresses. And it does that, show run interface, if I show you Ethernet 0.0, simply by enabling IPv6 on there. Of course, you have to enable IPv6 globally, router, IPv6 routing, or IPv6 unicast routing, or something like that. But once you do this, it configures a link local IPv6 address. And if we have a look, that's actually not in the routing table. If I go back to router 61 over here, and if I do show IPv6 route, and I can see I have got 1, 2, 3, 4. These are the 4 PE nodes, 65, 64, and 66, as well as my own locally connected on loopback 0. Pretty awesome, right? If IPv4 addresses are giving you grief and you're running out, then you know v6 or just use the same subnet for all of your transient point-to-point links on a site, and just don't advertise that out, because you don't need to route typically to a interface. You route through an interface and to a node, so to the node ID, to the loopback, if you like. But that's another day. I was playing and I thought, you know, I saw this before. When I first saw it, I thought it was really cool, and I wanted to lab it, and I thought, since I've gone to the effort of labbing it, I may as well share it, and if it's interesting, then give me a thumbs up. And if you're interested in anything else, I will get back to the SDA DNAC stuff. But you know, whatever I'm working on, whenever I've got the time. I've got life to live, wife to look after, and kids, and you guys aren't even real. It's just as virtual, and I'm rambling.